Hello everyone. Today, we're going to introduce a fascinating science experiment that helps us understand the mysteries of light, the Prism experiment. This captivating exploration of light begins with an object that you may find quite simple and unassuming at first glance. This object is a prism. The prism is a unique creation. It's typically made of glass or plastic and has three flat surfaces that meet at sharp edges. But the magic of the prism lies not in its physical form, but in the way it interacts with light. When a beam of light enters this three-sided marvel, it doesn't just pass through unaltered. Instead, the light undergoes a process known as refraction. Refraction is the bending or change in direction of light, when it passes from one medium to another of different density, in this case, from air into the prism. But the prism adds another twist to this tale of light. As the light exits the prism, it deviates from its original path. This is where the true spectacle begins. This deviation causes the light to spread out into its constituent colours. This process is what we call dispersion, a beautiful phenomenon that reveals to us that white light is, in fact, a blend of many different colours. Each of these colours has a different wavelength, and it's this difference in wavelength that causes each colour to refract by a slightly different amount, and hence spread out as they exit the prism. But why does this happen? Why does light refract and deviate when it enters a prism? The answer lies in the speed of light. Light travels at different speeds in different mediums. In a denser medium like a prism, light slows down and hence changes direction. This change in speed and direction is what causes refraction and deviation. The Prism experiment is a brilliant demonstration of these phenomena. It's a window into the vibrant world of light, opening our eyes to its many colours and how they come to be. It's a journey from the simplicity of a beam of white light to the complexity of its many hidden hues. With this understanding, let's now explore how the Prism experiment can be applied in children's science education. Now we delve into the application and inspiration of the Prism experiment in children's science education. The world around us is filled with colour, and this colour comes to life through the magic of light. The vibrant hues we see in rainbows dancing across the sky, the iridescent shimmer on a butterfly's wings, these are all beautiful examples of how light interacts with the world. So how does this relate to our Prism experiment? Well, these phenomena are all about the refraction and reflection of light. When light passes through a prism, it's refracted or bent, and this bending causes it to split into its component colours. This is exactly what's happening when we see a rainbow. The droplets of water in the air act like tiny prisms, refracting the sunlight and creating the spectrum of colours we see. And it's not just rainbows. The colourful patterns on a butterfly's wings are another example of light refraction. The tiny scales on the wings interact with light in such a way that certain colours are amplified, giving the wings their brilliant hues. By using the Prism experiment, we can help children understand these natural phenomena. The experiment is simple, but it beautifully demonstrates the colours that make up white light and the concept of refraction. It's a hands-on, visual way for children to explore the science of light, and the applications go beyond just understanding rainbows and butterfly wings. The principles demonstrated in the Prism experiment are foundational to many areas of science and technology. Everything from the design of eyeglasses to the creation of high-tech lasers relies on understanding how light refracts. So let's use this experiment as an inspiration for children. Let's open their eyes to the science that's happening all around them in the colours of a rainbow, on the wings of a butterfly, even in the lenses of their own glasses. With this knowledge, we can now perform the Prism experiment together. Grab a prism, a piece of white paper, and let's bring the magic of light to life. To ensure a successful Prism experiment, there are some specific steps to follow. The magic of the prism comes alive with just a few simple materials: a prism, a sheet of white paper, and a good source of sunlight. The prism, whether made of glass or plastic, should have three flat surfaces forming a triangular shape. A clear sunny day is the best time to conduct this experiment, as sunlight provides the most vivid spectrum. Start off by securing your white paper behind the prism. This sheet acts as your canvas, where the magic of light's refraction will be revealed. Make sure it's held steady, as any movement could affect the results of the experiment. Next, find a spot where the sunlight is abundant. Ideally, the light should be coming in at a right angle to the prism. You may need to adjust the position of your prism and paper to catch the sun just right. Don't be disheartened if you don't get it perfect on the first try. Remember, science is all about trial and error. Now project the sunlight onto the paper through the prism. As the light passes through the prism, it will bend or refract and spread out into a spectrum of 7 distinct colours. You'll notice that the colours appear in a specific order: red, orange, yellow, green, blue, indigo, and violet. This is what we call a spectrum, and it's the same phenomenon that creates rainbows. If you're wondering why the light splits into these 7 colours, it's because each colour has a different wavelength. Red light has the longest wavelength and is bent the least, while violet light has the shortest wavelength and is bent the most. The other colours fall in between, creating a beautiful rainbow of colours. This prism experiment is a simple yet powerful demonstration of how white light is made up of different colours. It's a hands-on way to explore the properties of light, the phenomenon of refraction, and the science behind the colours we see around us every day. But the learning doesn't have to stop here. You can take this experiment further by exploring how different types of light sources affect the colour spectrum. Or you could experiment with prisms of different shapes and materials to see how they change the results. The possibilities are as broad as your curiosity. Through this simple experiment, we gain a better understanding of light and the phenomenon of refraction. Remember, every great scientist started with a sense of wonder and a desire to explore. So keep experimenting, keep asking questions, and keep nurturing that curiosity. Who knows? You might just uncover the next big scientific discovery. The Prism experiment is more than just a fun activity. It's a gateway to understanding the intricate dance of light, a phenomenon we witness every day yet know so little about. This experiment unravels the mystery of how white light, something so simple and pure, is actually a symphony of 7 different colours. By passing light through a prism, we can see this symphony come to life on a piece of white paper. This experiment is not just about understanding light, but also about fostering curiosity, a trait so fundamental to science. It's not merely about observing the refraction of light or the resulting spectrum, but about asking why. Why does light refract? Why does it break into 7 colours? Why not 6 or 8? These questions are the essence of scientific inquiry, and this experiment serves as a launching pad for such questions. Furthermore, the Prism experiment introduces children to the concept of experimentation, a cornerstone of scientific thinking. It allows them to be little scientists, setting up their experiment, making observations and drawing conclusions. The joy of seeing the spectrum of colours for the first time, the excitement of understanding a scientific concept, and the thrill of discovery are all powerful motivators for children to delve deeper into the world of science. The Prism experiment also teaches children that science is not confined to labs or textbooks, but is present in the everyday world around us. It's in the rainbow after a rain shower, in the colourful wings of a butterfly, and in the white light of the sun. This experiment helps children make these connections and realise that science is not an abstract concept, but a tangible part of their lives. So, the Prism experiment is more than just a science experiment. It's an adventure into the world of light, a journey of discovery, and a spark that can ignite a lifelong passion for science. It's a tool that helps children understand the world around them and encourages them to ask questions, seek answers, and never stop learning. So, give this experiment a try and open up a world of joy and inspiration for the young minds around you. If you enjoyed this video, here are some more series that you might find interesting. First on our list is Exploring the Mysteries of Light, Laser Experiment. This series delves into the principles and methods of laser experiments and showcases how lasers are used in our day-to-day life. Quite illuminating, isn't it? Next, we have Marvelous Chemistry Experiments, a series that brings the exciting world of chemistry to your screens. It showcases varied principles and experimental techniques through a sequence of riveting chemistry experiments. Who knew molecules and atoms could be so much fun? Lastly, we have Hands-on Science Toys. This series teaches you how to create simple science toys, allowing the joy of scientific discovery to be experienced firsthand. It's like having a science fair at your fingertips. Remember, the world is full of wonders waiting to be discovered. So keep exploring and keep learning.